We're going to look at an introduction to a topic called contingency tables. Now, in this topic, essentially what we're doing is we're looking at two variables and we're going to see if there's an association between those two things. For the first question, we're looking at a type of crime and whether it was an individual or a type of business, in other words, the victim. So before we start the actual maths behind the question, it's worth thinking, like, would we expect there to be a link between these two things? Or do you think maybe that there's not a link between these two things? And that's what this test that we're about to do is trying to figure out. Like, is the type of crime associated with the type of business? Or are the two things independent of each other? And there's two ways it can be asked. Like, if you look at this question, it says test at the 5% significance level. We'll get onto that a bit later. If the type of victim is independent of the type of offence. When we're saying that it's independent, what that means is like there's no association between the two things. So there's two ways that we can word this. It might say test for an association, it might say test for independent. I've put the totals on already. Normally in the exam you will get the totals. If you don't get the totals, you will need to put them on because we'll need them. Okay. We're also asked to interpret our conclusion in context. It's quite a long method, this, so I'm going to take my time as we go through it. But essentially this example is the vast majority of this entire topic. It's just this one technique that we need to be able to do. And it's probably worth about 10 or 11 marks. So it will take us a little bit of time, and I'll go through it quite slowly. But once you've done a few of these, you will get quite quick, and it's not too bad. Okay, so we start always with our hypothesis. H0 is called the null hypothesis, and we would state that there's no association between, use the context, so type of crime and victim. H1, there is an association between type of crime and victim. It's very tempting to like just sort of skip this or just write ... but you do need to write that to get the mark. That's the first mark. Okay, so what we're going to do now is we're going to calculate expected values. And the expected value is the row times by column divided by the grand. So if we look at maybe this first value, 112, the row total is 220, the column total is 302, and then you divide by the grand total, which is 526, and that gives me 126.3117. Show this calculation, okay? So 302 times by 220 divided by 526, and that's 126.3. Obviously we're working with decimals now. We don't want to round too much here because we've got to be careful. We need to be accurate with our answer. If we use like 5 significant figures, that should be fine. Okay, so 311, that'll be okay. If we were going to do another one, so for the 108, you would be doing the row total, which would be 220, times by the column total, which would be 224, divided by the grand total, which is 526. But we don't need to we can do this 6 times, but luckily the calculator will do the scorers quite quickly, I'll show you in a second. But please, to get the method mark, show one calculation. At least one. Okay. Now, without the graphical calculator, we'd have to do all the 6 expected values, but I'll show you how to do it on the calculator because it does help a lot on this topic. So we want to go on to test. So menu stats, test, chi, because this is from the chi-squared distribution, 2a. And then it asks you for your observed matrix, so the actual values that happened in the sample. You know, 112 individuals were robbed, 108 businesses were robbed. We enter the observed values from the question. Okay. Now the way that we do this, first of all, we need to change the dimension of the matrix because different questions will have different amounts of rows and different amounts of columns. So press this one, and this is rows by columns, so 3 rows, 2 columns. I've already done this, but if you wanted to change the dimension, press F3 for dimension, so 3 rows, 2 columns, execute. Okay, then it opens up a blank matrix. I've entered my values in already. Okay, so if I was going to be doing this again, I'd be pressing 1, 1, 2, and then press execute, takes you to the next one. Okay, so enter the observed values in. Okay, now we've got to press exit twice. Okay, so remember to press exit twice, it takes you back to this screen. Once you've entered the observed values, press execute on the calculator. And then it spits out all this data for us. We'll come back to this in a second, okay, but this will be important, but let's not look at that just yet, because obviously if we were in the exam, this would be like 7 marks worth of work to get to this. We have to do a bit more work. What we want to first of all do is look at matrix B, okay? Matrix B will give us our expected values. See the one that we've just calculated? 126.31, okay? So that is a nice, one thing we're doing is we're getting a method mark, but we're also checking by calculating this that we've entered the values incorrectly. Like imagine if you entered one of the numbers in wrong, you'd be able to tell straight away because these wouldn't match up, okay? And you don't want to lose like 8 marks on this question. So just be aware it doesn't round them, it just sort of chops them. So if you wanted to get the other expected values, I'm just going to scroll across to see what they are, okay? So now you want to draw the table out again. Because I'm a bit limited for space, I'm just going to do it here. But you want the observed and the expected values next to each other. Okay. Actually, you know what? I think I'll use another board. One sec. Okay, so we got the original observed values, the expected values, which I'm about to type in. Oops, 103. Okay. So what's going on when we do this? Like instead of just getting lost in the numbers, just pause for a second and think about what we're actually doing. The expected value is sort of exactly what it means. Like that's what you would expect to happen. Okay. So if this was completely at random and there was no link, if there was no link at all, like no association between these two things. So if the victim, like individual person or business, and the type of crime, if people just committed crimes at random, you know, like I'm going to rob an individual, like the criminal thinks I'll rob this individual or I'll rob this business. There's no association, like no link between, you know, is he more likely to rob an individual, or are criminals more likely to rob businesses, or are they, you know, are arsonists more likely to burn businesses down, or are they more likely to burn individual homes? What if there was no link at all between these two things? This is what we would expect to happen for the numbers that we've got. So I would expect there to be about 36, 37 individuals who were victims of arson. Now in reality what happened was there was 44. So just before, I mean this is useful for when we come to interpret later, but if these numbers are far away from each other, that's going to be leading me to H1. Like remember H1, we're going to say that if there is an association between the two things, that happens when these values are far away. If the values are close to each other, in other words, what actually happened is what you would expect to happen. If there's not much of a difference between what happened in real life and what you'd expect, if they're close to each other, we'll just say, oh, there's no association because what we expect to happen is what we observe to happen. And that's like at the heart of this calculation that we're doing. We're just getting a feel for how far away these numbers are from each other. If the numbers are really far away, that means that, oh, more people than we expected were in this category. Fewer people than were expected were in this category. That's when you say maybe there is a link between the two things. Okay, so try and keep that in your mind for now, but let's not spend too long on that because obviously there's a lot of calculation that we've got to calculate as well. The next thing we need to show is our chi-squared test. Okay, and the formula for this is the sum of observed minus expected squared divided by expected. Luckily the calculator will do this for us again, but let's show the calculation. Okay, so what we're doing, we're going to pair these, we're going to have to do this calculation 6 times if we didn't have a graphical calculator. So the observed 112 minus the expected. When we're subtracting them from each other, mathematically what we're doing is we're figuring out how far away they are. Like if they were close to each other, these would be small numbers. If they're far away from each other, these would be large numbers. And the size of this value is going to help us to determine if they're far away from each other, something's going on. If they're close to each other, there's nothing really going on, there's no association. Okay. The reason we have to square it is obviously because if we just subtracted, some would be positives and some would be negatives. So we square, we divide by the corresponding expected value, which would be 126.31. And we would have to do this calculation 6 times, so the next one would be 108 observed minus expected squared divided by expected. Just do like plus dot 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 dot. You don't need to write it all out, but you do need to show for a method mark at least one. Okay, now if I was going to do this, it'd take me a couple of minutes on the calculator, but our calculator has done this for us. Okay, so if we go back to running the test again, okay, so if I go back to, let's pretend we hadn't done it, so we were back on the observed, we've entered our observed values, you press execute, it gives you out your test stat, so this value 8.01 is our chi-squared test. So 8.013, so it'd be 29, wouldn't it? So 8.013, 296, okay? So I'm going to use 4 significant figures for this. Remember, use at least 3, but I would always use 4, a minimum of 4. Okay, so our test stat looks like this. That would be a measure, basically think about this as a measure for how far away these values are, okay? Nearly done. Now we need to think about, once we've got this value, like what are we going with? Are we going to say, well, there's no association, or that there is an association, okay? One other thing as well I should have mentioned while we were looking at that screen, it gives you the degrees of freedom. So DF represents degrees of freedom, okay? In this question, the degrees of freedom is 2. The calculation for this is rows minus 1 times columns minus 1. So for our table, we had 3 rows and we had 2 columns. They quite often, I'm not sure why, they use letter V on the mark scheme. I'm going to call it V. I think you'd be fine with calling it DF, but I'm going to write V. So the degrees of freedom, also known as V, in this question would equal 2. you do want to write that down as well. Like there's a mark in the exam for writing that down. Okay. You'd maybe say DF, you can call it V, either one would be fine. I'm not going to go into what that represents, there's enough going on. Like if you look in the booklet we've given you, there's an explanation as to what that means, okay? Let's just carry on with the calculation. The last thing we need now is we need a critical value. Okay, so chi-squared crit. Now we're testing at, I should have highlighted this. It's asking us to test at the 5% significance level. So I would write down my chi-squared crit 5%. I would also write degrees of freedom, which is equal to 2. Just so you can distinguish, because sometimes when we're going to get two numbers, we need to compare the two numbers together. You make sure you label one the test stat and one the critical, just so you know which one's which, and also so the examiner knows that you've got the right values the right way around. Okay, so the way that we do this is back onto the normal stats mode, and we want to go on to distribution, because we're looking at a distribution. Now this is the chi-squared distribution. So distribution, chi, inverse chi, okay. Data, variable. Area is going to be 0.05. Because we're testing at a 5% significance level, where the area that we put in is 0.05, the degrees of freedom is 2. And if I press execute, it takes a second to think about it, but then it spits out my critical value, which is 5.991. Okay. Let's draw a diagram for the distribution. So the chi-squared distribution looks like this. It's like a one-tailed distribution because it's a squared. Essentially it starts at 0. You're never going to be getting like a negative test. If you get a negative test stat, something horrifically wrong has happened, because you know we're squaring these values. It's going to be a positive thing. This number here, essentially what this tells us, this 5.991. That one there is completely independent of the whole question. Like if I was testing at a 5%, so for any data at all, if I wanted to test at the 5% level and the degrees of freedom are 2, the answer would be 5.991. Okay, so what this critical value does is it separates into H0 and H1. Now we look at what actually happened in our question. Okay, and what actually happened in our question was the value that we got was 8.013. This is going to lead me to go with H1 and say that there is an association between the two things. Because we've got quite a large test stat, in other words, if we go back to what I was talking about earlier, these values are quite far away from each other, okay? So in other words, more individuals were victims of arson. Like there's a link between the type of crime and the type of victim. There is an association between these two things. It's not happening at random. You know, if you look at this one, for example, this one is business and robbery, isn't it? So more businesses were robbed than what we would have expected. Okay, you can interpret this in a couple of different ways, but there's clearly a link between what the victim type is and what the crime type is. So there is an association between these two things, which is what we're going to say here. Okay. One thing to go on, I know there's a lot going on here, guys, but we will do more hypothesis tests. It's like you'll see that there's like 3 of them we've got to look at. So this is the first one we've got to do, but it's like a common sort of thought process once we've done a few of these. When you're testing at the 5% level, what really we're saying is, with that being 5%, we're now 95% accurate. We're 95%, like in statistics you can never make a definite conclusion because we don't know. Like we've taken a sample, but the sample might, there might be a fluke sample, sometimes that happens, but if you're testing at the 5% level, we're 95, well, actually more than 95% sure of our conclusion. Essentially, there's quite a lot of evidence that there is an association between these two things. If the test that we'd have got would have been a small test stat, there's not enough evidence to say that there is an association between the two things. Okay? In other words, if the observed values and the expected values were close together, we'd say no association. But if the observed values and expected are far away, there is an association. So all we've got to do now is write our conclusion. Okay? And we'll start by saying reject H naught at the 5% significance level. The way I want you to set this out with your conclusion, right, you always refer to H naught first. But then we need to comment in context. And when we comment, we're commenting on H1. Okay? I would say evidence, never write a definite statement. So the evidence suggests there is an association between, context is key. In any statistics question, you need context. So we'll say type of crime or offence and victim. Context. And you want to think about H1. You'll see what I mean with another example, because if the conclusion was the other way around, we'd still start with H0 and then context H1. It's just the best way to set this out. Interpret the conclusion in context. So let's go back to what I was saying before. Where's the sort of a big difference? I mean, they're all quite far away from each other, aren't they? I mean, we can interpret this in a couple of different ways. We could say maybe if we look at this one, 108 and 93, or maybe proportionally it's probably this one that's the biggest, isn't it? So you could say more individuals, because this one was the individuals, this one's the arson. So more individuals than expected are victims of arson. Okay. So to interpret it in context, if we were asked, and this you'll see this quite often, and whenever you end up rejecting, when we're saying essentially what's happening here, when we're saying that there is a link, there is an association between these two things, you will probably be asked to sort of dig down and say, well, what is the association between them? You're saying there's a link, but which way does it happen? So like we can just look at the observed values, look at the expected values. You need to say than expected, okay? So more individuals than expected are victims of arson. I mean, we could also say, for example, if we looked here, what's going on with this one? That's the businesses, isn't it? So more businesses than you would have expected. 108 were robbed, sorry. We'd only expect it to be 90. So more businesses than expected were victims of robbery. Okay, what's going on with burglary? Individuals, so more individuals are burgled than what you would have expected. And obviously if it works that way around, it's the opposite the other way around. Fewer businesses than you would have expected. Okay. I know there's a lot going on there, guys. Sorry, it's quite a long one as well, but we'll get quicker once we do more of these. That's the sort of the thing that we have to do each time. Okay, thank you.